Welcome back, and in this lesson, we're going to learn about system load averages as well as using the top command. Now, the first thing I'm going to do is I'm going to show you a few commands available. We have the W command, which is going to show us users online and our system load average and uptime. If we do uptime, it's also going to show us our uptime and system load average. Now, what I want to do is I'm going to teach you how to read our system load average. This represents our load average for the past 60 seconds, 1 minute. This represents our load average for the past 5 minutes. This represents our load average for the past 15 minutes. Now, how you look at this really depends on your system. If your load average, probably primarily concerned about the last minute. This is really a historical record for us, so if we came to see if our load was above, we can see that, all right, well, there was a higher than normal load for a specific time period. Now, this really tells us the percentage of CPU processing power that's being used. That's what our load average determines. So, for example, if we have one processor, then 1 would be 100%. 1.00 would be 100%. So if our load average was 1, that means we would be using 100% of our CPU processing power. If we had 2 CPUs, and our load average was 1.5, that means we would be using less than the available processing power. So what I want to do is I'm going to teach you how to calculate the percentage of processing power, especially if you have multiple CPUs. So first, we need to figure out how many CPUs we have on our system. I can do that by taking a look at my /proc/CPU info file system. If we look for a tag that can identify some information here, for example, model name, this will display every model. Now, what I'm going to do is I'm going to open up a tab inside of my local host, because inside of my local host, I'm also running a Red Hat machine. And if I take a look at my proc CPU info file, now the proc file system is a pseudo file system which really is used to interact with kernel. It shows process information, kernel database information. That's how we can view information from our kernels using the proc file system. Now, if you notice here, I actually have 2 processors. Now, what's unique here is that what I want to do is I want to count the number of processors I have. So if I have 2 processors and I look at my system load average, that really skews what this means to me. So how do I do this? Well, I'm going to go ahead and you can use your lab servers, but since our lab servers only have 1, the way we read uptime or load is that our CPU average here load is 10, for example, on our lab server. Since we have 1 CPU, we're using 10% of our CPU processor. If we had 2 CPUs, we would only be using 5% of our CPU processor because each one of these represents the number. Now, what I'm going to do is I'm going to go ahead and do while true, do echo-n my program. We're going to pipe that into output.file, and I'm not going to sleep it at all. And in fact, I'm going to run this in the background. Now, what this should do is this should steadily start to increase my CPU power. See what's happening here? We're increasing the amount of CPU utilization we have. That program is going to steadily do that. Now, I could start this program multiple times, and we're going to see our processor increase. So we're now using 54% of our processor. So let's say I want to calculate my load while that's increasing its processor. I'm on my local machine here. What I need to do is I need to view or find the number of processors I have on my machine for my calculation. So I could do a cat proc CPU info. Now, I could go and count the output, or I could pass it to my grep command and look for model name, because I believe that was one of our options, and then count it to our word counting program. This will count WC's word count. And I can count the number of results here based off this by doing the -L. So it's going to count the number of lines that are outputted. So I have 2 processors. So my calculation is going to be my current processing power divided by 2. So if we were to go look at our processor here, we're using way more than 100% of our processor speed. This is going to be an issue when it comes to capacity. We actually need more processors. We're using more processing power than we have. And what happens? Well, a lot of stuff's going wrong here. We wrote too much information. Our device itself is done. So Because of that, I'm going to go ahead and just terminate my linuxacademy.com live server and continue on my local host to demonstrate this with 2 CPUs that we have available to us. So what I'm going to do is I'm going to write this while true script again. So we'll do while true do echo hello world -n into our home directory file dot output. Then we're just going to be done. We want to make sure to send this to the background. Now I'm going to do this several times and we're going to see our processor speed increase. So you see 38 here. So my calculation, since we've done this command here, since I have 2 processors, my calculation is going to be 0.38 divided by 2. So if I open up a calculator and I look at this math, 0.38 divided by 2, we're currently using 19% of our processor because we have 2 processors. Now, if you look at it here, we're using so much processing power now that we're now at 2. So if we did 2.19 divided by 2, we're actually using more than 100% of our processing power. So I'm going to go ahead and make sure I terminate these jobs. I'm just going to do a quick kill, kill, and we want to make sure that we kill job 1 and kill job 2 and job 3. That way our processor's going to not go to capacity again, but our processor speed's going to go down. So if we had 4 processors and our load was 2.98, what do you think it would be? It'd be 2.98 divided by 4, and that's going to be 74%. So the number of processors really affects how our CPU load average works. Even though this number doesn't change, what the number means does change. So another way of doing this, now you can stay on your linuxacademy.com lab server. All of this is going to work the same, is we have a program called top. This top program is going to provide some information about my system. Now, immediately what I see here is I see my uptime information and load average. I see my task information, the number of processes running, 264 total, 1 running, 244, 46 sleeping. And we see the available memory that we have to us. Now I can toggle this by hitting the M key. I can toggle my memory. I can hit the T to toggle our tasks, right? So we have tasks and the amount of CPU utilization that they're using or percent of CPU. And I can also toggle out my uptime there. So I can hit L. So I can toggle all of that information back and forth between using L, T, and M. I can use B to bold if you see what's happening here. If I use a capital B or Shift B, uppercase B or Shift B, what's happening is we're bolding information back and forth. So it's a little bit easier for us to read. Now, the cool thing about this program is we're able to see what might be utilizing a lot of processing or even memory on our system. So for example, if we have a script that's using a lot of our CPU processing power, maybe if we come back to our while true script that we created, it's going to, if you see here, we now have a bash script that's running. This is sorting based off percentage of CPU that's running. So let's talk about this. This percent CPU is the task's share, this individual task's share of elapsed CPU time since our last screen update. So our screen updates, as you can see it updating in real time here, every couple of seconds. Now, when I start this program, I can specify the amount of time or how often a screen updates. We'll talk about that in just a minute. So this percent memory says the task's currently used share of available physical memory. The time is the CPU or the total CPU time the task has used since it started. So basically this has been running for 40 seconds, or it's been using the CPU for 42 seconds or 45 seconds, however long since it's been running. Now the task could be doing nothing and sleeping, but it's going to say how much time has the CPU used. So I can say, hey, this is using a lot of processing time. This is using a lot of processing power. Percent of our CPU, 83. Now we see the user who started it, Anthony, and our res here, what this is the non-swap physical memory a task is using. And then we have SHR, which is shared memory size or the amount of shared memory available to a task, which means this task might be using or sharing memory with other processor tasks on the system. Right, so we see that this process is an issue. I can give it a higher priority if I want this to complete faster. Let's say this is hypothetically a backup process, and I really want this process to hurry up and complete, or I think it needs priority. I can hit the R command to renice it, and I just enter in my PID. So I can do it 32465. And it's going to ask for my nice level. So let's give it a -20 nice level. Well, I have permission denied. That's because I'm not a privileged user. So if I do a sudo su and I go into my root user, or if I do an su dash to go into my root user, because we've remembered that regular users can't decrease their priority or tell a process that it does not have as much priority, but it cannot increase the priority. Or in other words, create a lower nice level, but it can add a higher nice level. Now remember, the lower the nice level, the higher priority. So I'm going to renice this. I'm going to enter in my process ID 32465. And I'm going to set it to a -20 to give it the highest amount possible. Now this NI here, this is our niceness level. So it's running at a -20. So this process would be designated more priority over all of these other guys to maybe hurry up and complete. Now, there is no end game on our process. It's an infinite loop until we kill the process. As you can see here, we're sorting by percentage of processing or CPU. So maybe I want to sort by used memory. I want to see a program that might be using a lot of memory. So I'll hit Shift M for uppercase M. And you can see now that we're sorting by the amount of memory used. A Shift P, which is an uppercase P, is going to go back to sorting by CPU. Now, I'm about done with this program. I don't know what it's doing. All I know is it's part of my system and it's taking a lot of CPU and I need to kill it. Right? So we know what it is, but this is a hypothetical scenario. So I'm going to hit K and then the process ID, which is going to be 32465. Now, the reason this is the default is it's one that we just used. So I can just go ahead and hit enter, and it's going to ask me for my signal. I'm going to say, all right, do a signal 15. And you notice our priority is now gone. You notice that that process is now gone. It's no longer running. So that's how we use the top program. Now, a few tips and trips with the top program is I can do a top-n. Now, what the -n flag does, it says update this number of times and then quit the program. So if I do a top-n2, it's going to update twice and it's going to close back out to our terminal command prompt we see here. So if I do a top-d2, what that's going to do is it's going to set the number of seconds between each update. So every 2 seconds, this is going to update. Or I can set it to every 1 second. It's going to pull our new information. So we see it very quickly changing here. Or I could say update every 20 seconds. So our screen here won't even update for 20 seconds. So that concludes it for this lesson. Go ahead and complete this lesson and move on.